Assalamualaikum and hello everyone. We are going to explore an interesting experiment about how to determine the focal length for a convex lens. So, yes dear, it's all about the geometrical optics. I'm Madam Titiaka from Unit Physics KMPK. We can burn this cute balloon using the magnifying glass. Okay, let's look closer about that. Wow, it's great. We can even burn our popcorn using the Fresnel lenses by adjusting the focal length. Okay, so this is two applications in our daily life. Let's go to our lab, and before that, please make sure you are ready with your manual lab and your jotter book. It's time to give you an overview of the whole procedure. Use the convex lens to focus an object on the screen to estimate your f0. Measure the height of object h0. Place the object at a distance between f and 2f and find the sharp image on the screen. Measure the image distance v and the height of image hi. Repeat the experiment for 6 different positions of object U between F and 2F. We will use the equation of M is equal to Hi over H0 to calculate the magnification. Remember, the Hi must be negative because the image is inverted. You can use the equation of M is equal to negative V over F plus 1 to plot your graph, and the gradient will be negative 1 over F. Your graph is going to resemble something like this. Theoretically, you will get at y-intercept at positive 1. But you might get a different value, and it's okay. This just gives you more room to discuss at discussion section at your lab report. From the graph, you can determine the focal length of the lens from the gradient of the graph, and by using the extrapolation, when m is equal to negative 1, the image distance will be equal to 2f. Make sure you are record uncertainty of your measurement in the measurement column. Label each column with its symbol and units. For a value that are too small or too big, remember to write in a standard form, and don't forget your exponential power at the top of the value in the column. Now, we are going to introduce the apparatus and experimental setup for you.
Now, we are going to get to know the apparatus. We will use a convex lens with a holder, a bulb for a light source, a cardboard with an arrow slit as an object, a screen where an image will appear on it, then a power supply. First of all, the very important thing before we start the experiment, we must obtain focal length f0 of our convex lens. It is just simply use any object outside laboratory such as tree, building or anything, focus to the lens and find the sharp image on the screen. Measure the distance between the screen and the lens. Now you got your focal length f0. Measure the arrow with a ruler for the object height. Then, we are going to connect our light source to the power supply. For this one, I am going to use 4 volt and choose the direct current. Place the cardboard in front of the light source. Convex lens is placed in front of the object. Lastly, place the screen. Using a ruler, place the lens at 2F and mark. Place the object at distance bigger than F. Object distance U is measured between the cardboard and the lens, while the image distance V is measured between the lens and the screen. Now, move the screen until a sharp image is appear. As we get the sharp image, measure the image height. Repeat again step by step by adjusting along the ruler between F node and 2F node for 6 reading. This includes the value of the object distance, the image distance, and the image height.
You are going to repeat the experiment until you have 6 sets of U, V, and HI. That is it for the video. I hope it will help with the experiment. Should you have any inquiries, please consult with your practical lecturer. And thank you.